Good afternoon, grade 9s. Just a lesson on straight lines. Firstly, they say learn the theory, and the first thing is something you've learned in grade 8, and that is that adjacent angles on a straight line add up to 180 degrees. Okay, and that would be when the two angles are situated at the same point. They come from the same point, B in this case. Okay, so this angle is called B1 and this angle is called B2, and together you see they form a straight line, and therefore they should add up to 180 degrees, and that is only because they're adjacent, which means next to each other. Okay, and have a look here. That's how you would write your reason. So your statement would be B1 plus B2. Do you see that over there? That indicates that it's the angle at B1 and the angle at B2, and if you add them together, that it gives you 180. So this part would usually be your statement. Okay, so this is your statement. Remember, you're supposed to write a statement and a reason. Okay, and then your reason is over here. That's your reason. Okay, adjacent angles on straight line. We already said that it adds up to 180, so we don't need to say that in our reason again. The statement is the angles would be 180 together because, that's most what a reason is, because they're adjacent angles on a straight line. Okay, we're going to have a look at some examples just now. Then the next one is angles about a point add up to 360 degrees. In other words, once again, they come from the same point, so we can label this O or whatever we like, but then A, B, C, D, E, F all come from this same center point over here, and together they add up to 360 degrees. All right, so your statement will look something like this. Over here, this is your statement. And then they say on top here that your reason is angles about a point. Okay, so we say in the statement that it adds up to 360, and then in the reason part we say why, because they're angles that come from the same point. They're angles around a point. Okay, and then in the next part, when two straight lines intersect, the vertically opposite ones are equal. Okay, the same size. They form the same size because it's a straight line intersecting a straight line. And now the statement is on the next page, but I'll just write it here for you. So your statement would be that A is equal to C. So as you can see here, A is opposite C. So when two straight lines intersect, we don't call these angles opposite, we call them vertically opposite. So we're going to say A is equal to C, and the other two angles opposite one another would be D and B. So B and D would have the same size. Okay, and then you can say this is your statement over here, and then your reason would be that they're vertically opposite angles. Okay, so why are they equal? Because they're vertically opposite angles. The next thing, remember to use statement and reason columns in your exercise book, and then you can see the statements that was supposed to be on the previous page here at the top, but I've already written it in for you. Okay, so here's an example of how you use the statement reason block, but I'm also going to illustrate that in the examples. So we would, for example, say the statement is that we know, the knowledge we have is that A and C would be equal in size because in the picture they are vertically opposite angles. Okay, so in geometry, a statement is when you use the knowledge you have about, for example, a straight line to set up an equation. So we make up an equation to convey the knowledge that we have about what we see in the diagram. So In other words, in this case, if it's a straight line that the angles next to one another add up to 180. And then the reason is to say why we say what is in the statement. In other words, like I've said, with the three things that we went through, the two angles add up to 180 because they're adjacent angles on a straight line. We just use certain abbreviations for them, and that's why we wrote in brackets the reasons for you guys so you can see the abbreviations. First example. In this example, as you can see, we're working with a straight line, and then there's a line that comes from D over here. And then, therefore, I am able to notice that 2x plus the 100 degrees next to it over here, they together form the actual straight line AB. So together those two angle sizes should be 180. So whatever 2x may be plus the 100 degrees angle next to it, that's adjacent to it, together they add up to 180. Okay, that's my statement, the knowledge I have. Why do I have this knowledge? Why does it add up to 180? Because we know that they're adjacent angles on a straight line. And now I don't want you to just write angles on a straight line. It's very important that you also write adjacent angles on a straight line. Now we go ahead and we solve the equation that we put together in the statement column. And so we use our inverse operations. But I'm not going to write them out like I did with the algebra. You guys should be familiar with all the steps by now. So we subtract 100 from each side. So 2x would remain on the left-hand side. And then on the right-hand side, 180 minus 100 gives you 80 degrees. And then we divide by 2 on each side, and that gives you that x is equal to 40 degrees. And that gives you the size of x. So let me just put in here, solve for the variable each time. That's our objective throughout these examples. I'm going to say variables. Okay. Example, we have two lines intersecting one another, and we can see here that, remember, when two lines intersect one another, we can actually work with angles about a point as well as vertically opposite angles. It just depends on the information given to us other than the variables, whether we can relate it to angles about a point or vertically opposite angles, or even adjacent angles on a straight line. Actually, we can still see that this is a straight line. Let me just use the highlight here. This is a straight line, okay, and therefore x and 94 should be adjacent angles on a straight line. They're 180. Okay, so in this we can therefore go ahead and say x plus 94 is equal to 180 and solve for x, and then we can after that solve for y. But something else I noticed, so there are plenty of ways, before I carry on with that sentence, plenty of ways in which to solve certain diagram values in so many of the geometry diagrams that you're going to come across in future. But find the best one that fits your style, your way of doing things. The easiest first thing that comes to mind. What I also see, of course, is that y and the 94 degree angle are angles opposite each other where the straight lines intersected. So therefore y should be the same size as that 94 degree angle. The reason being, like I just mentioned, vertically opposite angles. Okay, we just say that. We've already said that they're equal. And I also know x is equal to x, and it's already clear, but now you can solve x by angles in a straight line, or you can use angles about a point. So I'm just in this example going to use angles about a point so that I can show you how to make use of it as a statement and a reason. So how angles about a point works is we know all together all of these angles add up to 360 degrees. So x and y and 94 degrees should give you 360 degrees. And the reason, we always just write the reason next to the statement that says, for example, it adds up to 180 or it adds up to 360 or they're equal in size. So angles about a point or around a point. And now we simplify on the left hand side. We already know the value of y and we can therefore substitute. You can even completely skip this step immediately onto this step which I'm doing right now. 2x plus 94 degrees plus 94 degrees equals 360 degrees. And then we solve for x by adding 94, which gives you 188. So 2x plus 188 degrees gives you 360 degrees. And now that means if we subtract 188 from each side, that 2x remains on the left hand side, and on the right hand side we are left with 72 degrees. Last step to solve for x would be to divide by 2, and then 1x would be equal to 36 degrees in size. And that would be all you do in this section. Okay, people, so you can carry on with the work given.